In this question, we are given this scatter plot. It shows the age of a tree as a function of its diameter. So age is measured in years, diameter in inches. So this was the setting we were introduced just in the previous question. No? So what is important to understand is that the data points here come from a single type of tree, single species. Remember, we were given 8 type of trees, species in the previous question. Well, all this data pertains only one of these species. So there are 26 data points here. So what they did was basically look at one of those trees with various types of diameters and calculated the age of the trees using our tree age calculation formula, no? This was how we calculated the age, no? Age was found by multiplying the diameter by its unique growth factor. So since they know this tree, they know the growth factor, no? Which is a constant number unique to that tree. So they know various type of diameters of 26 trees. They know the growth factor, they multiply it, they calculate the age. Basically, that was how this data was collected and then plotted here. So what do they ask us here in this question? They say, we give you this scatter plot. Can you tell us which tree it is actually that we used in charting out in constructing the scatter plot? So which tree is this? Well, look at it. Age is it's my y-axis. No, this is my y variable. The diameter is my x variable, and GF, the growth factor, is just a constant. Let's say A. No. So mathematically, this formula is simply y equals ax. So it's a constant here. So this is like our slope-intercept formula from the origin. No? So that will be a good approximation. They're also saying like what is the closest that you can find, so we can make like rough estimations. So mathematically we are looking for this. Well, we know the age, we know the diameter. They're on the data given on the chart scatter plot given to us. What we don't know is A. A is just the growth factor. So we are gonna try to find this. So how can we find it? Note, this is the slope-intercept formulation of a line. Well, the y-intercept, because it's like line from the origin, it's like 0, no? But this is the slope-intercept formula for a line. Then what is A? Mathematically speaking, this is simply the slope here of the scatter plot. Well, scatter plot is just many data points, 26 specifically for this one. But looking at a scatter plot, we can construct a line of best fit, which has a slope. Line of best fit is linear, no? So how do we draw a line of best fit? Well, we just look visually and we just take our pen and like make a direct increase in this case, no? Straight line in the midway between these two, among these 26 data points. So the idea should be there should be, obviously I haven't been very precise here because I'm just being very amateurish about this, as if I'm using a board here, that's my goal. There should be equal number of observations on the top of the line and equal number of observations at the bottom of the line. So this is a good approximation to describe the behavior between the tree diameter and its age. So since we are trying to calculate this slope, now this line can give us a good estimate for this slope. So if I have this line, how can I calculate the slope? Well, slope is just m, no? We denote slope by m, but this is now going to be my growth factor. And once I know the growth factor, I'm going to be pinned which tree we are talking about. Okay, going back, how will we calculate the slope once we know we have this line? Well, it's always enough to just pick 2 points on the line, no? We can roughly take any 2 points, whichever we want, but Let's pick 1118 and 1510. I also tried 1290 and 1510 here. It also gives a good approximation. It still marks the same unique type of tree. But let's try this one. So how do you calculate the slope given 2 points? Well, it is change in y over change in x, no? Change in y is change in the y coordinates, 110 minus 80 over change in x coordinates, 15 minus 11. So this is 30 divided by 4. So this is 7.5. So the slope is 7.5. Well, that is my growth factor, no? So I'm going to be looking for the tree that has growth factor 7.5. And looking at the previous table we were given in the problem, we see which tree that is. Which tree is that? That is bark. It has this strange name, no? Shag bark hickory. So that's the type of tree at the last line, no? Shag bark hickory. That has growth factor 7.5. So that is, looking at the choices, that is choice D. It's right here, never know. Shag bark hickory, whatever. Okay, that's our conclusion. So we are done here.